Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 1 from lesson 6-2 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to rewrite an exponential function to identify a rate. Now this question's a little bit, or this title's a little bit misleading because we already have a rate, we just mean a different rate. So they're trying to break it up into different types of units, right? Like we usually have an annual rate. We might be looking for like monthly or quarterly, something like that. So what I did was I actually just cut and pasted what was in the book here for this one, and then I'll walk through step by step on the other one. I just want to explain what it's saying, okay? So in 2015, the population of a small town was 8,000. All right, so that's our initial amount. The formula that they're starting with here, y'all, trying to remember what it looked like when we presented it last time, but it's something like this. Okay, so they're taking their initial amount of 8,000 and plugging it in for A. Okay, now the population is increasing at a rate of 2.5% per year. Now, kind of the key thing here, y'all, is that you can't put a percentage into an equation. So do you notice how they changed it to 0.025? And so then it says rewrite the exponential function to find a monthly growth rate. Okay, so here we are. So there is our formula. And the first thing that they did when they wrote out this formula was what we all do, right? Is they combined the set of parentheses together. They did that addition. Alrighty, so now that they've done that, this here is where things start to get a little interesting. Okay, what they are doing here is they are multiplying the exponent by the number 1. Right? Now remember, when you multiply by the number 1, you don't actually change that value, right? So they are not changing the value of the exponent, okay? Because if they changed to the value of the exponent, it would change this entire model. So that's why they're multiplying by 12 over 12, because 12 over 12 is the same thing as 1. It just looks a little funny. And you're going, well, where's that 12 over 12 coming from? Why 12? That's because we're looking at monthly growth rate. So there's 12 months per year. Okay. If I was trying to find a quarterly rate, like we're going to do in just a second, I would be doing 4 out of 4. If I was trying to look at weekly, I'd do 52 over 52. Okay. So now that they've multiplied the exponent by the funky number 1, you have to remember that when you are dealing with exponents, we have this part down here, which is actually a root, right? The 12th root. And we have this part up here, which is the exponent, like the power. And you could choose the order in which you resolve those. So I could choose to do the exponent first, or I could choose to do the root first. In this type of problem, I'm going to do the root first, because the root is generating that rate. Okay? So all that they did was they absorbed that root into the parentheses. And then they actually took that root. Now remember, if you think back to our original equation, remember, this is our a, this is our 1 plus r, here's our x. So all that stuff that's in the parentheses is the same thing as 1 plus r. Alright, so that's what we're kind of investigating in that text down below, is that 1.00206 is the same thing as 1 plus r. So if I go through and I subtract 1 from this thing, that leaves me with my rate. And that's exactly what they do here. So they do that value minus 1. Now here's our rate in decimal form, but we probably wanted it as a percentage, right? That's how we usually do it. And so they move that decimal 2 units to the right, and they got their monthly rate. So we're going to go through that process again with that same population of 8,000, okay? So remember, I'm going to say A is 8,000 for the initial population. Our annual rate, our R, is 1.8%, so that's 0.018. And I'm doing it quarterly. Okay, so I'm going to make sure to write that word down so that I remember I need 4 out of 4 for my exponent, okay? And please ignore this box. I use this to present to my students and I have them try it in these boxes. So here's my formula. Now I'm going to plug in my A and my R, right? So I have my 8,000 population and my rate of 0.018 to the x. So I want to clean up those parentheses, right? I don't want to have some weird equation in there. So there we are. There's our equation. Now, okay, I'm just going to write plug into equation. So now my next goal, I'm going to split the exponent or multiply the exponent by 1. So let's see what that looks like, okay? So the first thing I do is I take that exponent, and this is where we are getting the quarterly part to it, okay? I'm multiplying that exponent by the number 1. But in this case, because I want it to be quarterly, I'm going to make that 1 look like a 4 over 4. And then we take the bottom of that exponent, and that's what we're going to kind of suck inside of this parenthesis. Should have left myself a little bit of space, y'all. So the bottom of the exponent is going inside the parentheses as a 1/4. All right, and the top of the exponent stays on the outside. And now I'm going to go ahead and take that 4th root right there. Okay, so I need help from Desmos to do this one, so here we go. 1.018 raised to, and you could either raise it to the 1/4 power, or you could figure out how to type a 4th root. I'm going to show you how to do that. If you want to do a 4th root, you click your keyboard, go to Functions, Miscellaneous, and here's an nth root. So I could have typed it in like this and see how I'm getting that same answer. Alright, so here's my big ugly number that I'm snipping using the snipping tool. Because by now y'all should know I have no memory whatsoever. So there's that. Ignore the equal sign, okay? Pretend that equal sign's not in there. Alright, so now here's where we need to remember that this number that's inside the parentheses is the same thing as 1 plus r. So I'm going to set the parentheses equal to 1 plus r, and then convert r to percentage, okay? So I'm going to say, well, 1 plus r is equal to that hideous number. So if I subtract 1 from each side, I get a rate of 0.00446994004, and then I convert it to percentage, right? Because we only want this in percentage. Now, because our previous rates have been just kind of 2 decimals, I'm going to only show 2 decimal values. So I'm going to call it a 0.45%. Like Savvas is usually really good about telling you what to round to, right? So that's what I would look for. Alrighty guys, so there you have it. That is how to rewrite an exponential function to identify a different rate. Until next time.